Hong Kong, a compacted city, with only 7 square kilometers active farmed land, cannot maintain the food supply for its citizen. Therefore, over 90% of food in Hong Kong is imported food. During the process of food importation, including production, packing, storage and transportation process, a great amount of greenhouse gas will be emitted. However, the condition of packing and storage varies a lot. Therefore, we assume that the total carbon emission of food importation in Hong Kong is equal to the on-farm emission plus the transporting emission. The on-farm emission is equal to the imported quantity times the on-farm emission intensity. These data can be found in the FAO's database. The transporting emission is equal to the food miles times the greenhouse gas emission factor. The food miles is equal to the imported quantity times the distance. Generally speaking, the distance is the distance between the farm to fork. However, due to the transporting route before exportation and after importation is uncertain, we assume that the distance here is the distance between port to port. Consequently, we get the total carbon emission data. In 2016, by importing beef, lamb, pork and chicken, 21.6 million tons of carbon is emitted, in which beef provides 86% carbon emission of total carbon emission accounts. The total carbon emission intensity of beef and lamb are 28 and 27 tons carbon dioxide per ton of product respectively, nearly 14 times and 45 times more than those of pork and chicken respectively. That's the reason why the imported quantity of beef is less than pork and chicken, but its carbon emission is more than pork and chicken. According to Hong Kong's Climate Action Plan 2030+, by 2030, the carbon emission of Hong Kong should achieve a reduction target of 26% to 36% using 2005 as the base. So, we assume that the carbon emission of food importation in Hong Kong should achieve a reduction target of 30% by 2030 using 2005 as the base. According to Interpolation, if 2016 is used as the base, the reduction target is 17.3% by 2030. In order to achieve this reduction goal, we propose 2 strategies. First, changing the diet habit. Second, imported quantity adjustment. As to the strategy 1, changing the diet habit, the government should recommend the public reduce the consumption of beef and lamb by eating pork and chicken instead. As this nutrition profile showed, the nutrition of these 4 kinds of meat is similar. So, strategy 1 is totally workable, and won't do harm to human body. However, strategy 1 is not mandatory. So, here comes the strategy 2. Imported quantity adjustment. For example, the total carbon emission intensity of country A is 2 tons carbon dioxide per ton product, while the intensity of country B is 4. The imported quantity from country A and B is 100 and 200 tons respectively. Then, we reduce the quantity from country B and add it to country A. By doing this, we can reduce the carbon emission without changing total imported quantity. Therefore, we propose a quantity adjustment plan for traders. The principle for this plan is that higher the total carbon emission intensity, the less the imported quantity should be, vice versa. After quantity adjustment, the total carbon emission of food importation reduces 18.6%, which means this quantity adjustment plan can meet the requirement of the Hong Kong Climate Action Plan. However, the cost, in this case study, due to the uncertainty of the packing and storage, we assume that the total cost of food importation is equal to the ex-works cost plus the freight. The ex-works cost can be found in FAO's database, the pump price for freight calculation can be found in World Bank Group's database. However, after quantity adjustment, the cost of food importation increases 6.3%, in which the cost of importing beef, lamb and pork increase 9.3%, 0.2% and 7.8% respectively. The cost of chicken reduces 0.1%. Who should afford this cost increment? The government plays an important role in this case. The government should find a balance between the interests of the public, traders and itself. If the traders put up the price of the food, the cost of living of the public will be increased, consequently, the public will say no to this reduction plan. So, in this case, the government should publish the policy of carbon label to reduce the cost of living of the public. Carbon label is something like this: by tagging different carbon label on different kinds of food, the public could know the carbon emission intensity of the foods. The green label means a lower carbon emission intensity. The public could collect the green label to a certain amount and get cash back from the government. If the traders do not put up the price of the food, the cost of trading will be increased. So, no trader wants to do this. Therefore, the government should publish some supporting policies, such as giving them subsidies or lowering their tax, to encourage the traders who import food from low-emission intensity countries. The government could also impose carbon tax on those traders who do not join in this reduction plan. However, because the food is directly related to the happiness of the public will have many concerns on the reduction plan, such as why should I pay more on low-carbon intensity food while some factories are still emitting a terrible amount of greenhouse gas? Why should I pay more for this plan without seeing any short-term benefits? Therefore, the government should be very careful in the decision-making process. Before making any decision, the government should hold some hearings to collect the opinion from the public.